And I'm going to get the diagram over here across. Bear with me. I do apologize. I don't mean to make you guys go so confused, okay? Right. So if we were to look at this vector, right? We know that the omega p, right, is in a clockwise direction, right? So we know that omega p is in the clockwise direction. So when using equation 1, when using equation, did I write equation 1 properly? Yeah, for minus 0. When using equation 1, yeah, so when we adopt to equation 1, we write what? In I component, we know that Vp, right? Because we know that it's going towards the what? We assume that it's going towards the left is correct. We assume. So when that's the case, right? We write minus Vp is equal to minus 0.4 plus by 0.04, and then we put in omega p. Okay. Now down here, we have to be very, very careful. Did I write the radius properly? 0.04. Wait, 0.0. Yep. So over here, we write minus Vp is equal to minus 0.4 plus by 0.04 multiplied by 5. Okay. So over here, you have minus Vp is equal to minus 0.4 plus by 0.04 times by 5, 0.2. So therefore, Vp minus Vp is equal to minus 0.2. Vp is equal to 0.2 I, or 0.2 meters per second. So what this means, I put a minus down here because we assume this direction. If you don't put a minus there, you have to flip. Are we clear? Okay. So over here, the assumed direction is what? Is correct. Yes. Repeat your question. Yes. Is the planet is 5 radians per second, and the sun is also 5 radians per second. But the linear velocity are not the same. It's possible. Yep. Yes. Say it again. Yeah. The linear velocity can be the same. Linear, did I do something wrong with my cup? Okay, wait. I rather than repeat the remark that you have made. So the concern is this. this is going at 5 radians per second. And your concern is this is also 5 radians per what? Second. That is your concern, right? And the other student, where are you? Yep. Is that also your concern? Okay. 5 radians per second. The ring gear is at 0. Oh, you guys got me thinking this time. I'm just doing the math and not asking why. The assumed direction. 0.04. Did I miss anything in my calculation? Hold on. When I get 5 radians per second, 0.4, that's 5 radians per second. 0.4 Vs is equal to 0.4 SR 0.08. This is correct. These two are correct. Yes. So what you're telling me, gear train theory won't work? Is that what you're telling me? Okay, let me find out this one. Okay, because as I said, I did not know how to calculate the gear ratio of planetary gears. I forgot. Okay, let me find about this. Okay, I'm not excluding your remark. Okay, but based on the math, it is the same. Okay, I don't think I make any mistake, but let me check. Okay, good point. I want you to do this. Okay, so Eugene, check the validity when planet and sun gear are the same angular. I'll check. Okay, I won't stay down here and speak louder to you to say that this is right. Okay, let me check. Okay, good point. Okay, as I said, I've not thought about it. Okay, but for now, we know that the velocity of the planet is what? It's running at 0.2 meters per second. Okay. Now, the next thing we have to find is, let me get the figure over. Okay, I will check. Okay, I will not go louder at you. Okay, I will check. Okay, then I'll answer you. I don't want to say something that I'm not sure, and then or go louder and then make you accept the fact. Okay, that's not right. That's how I'm treated. I won't treat you that way. Okay. My prof just go louder and I say, oh, all right, all right, all right. So the last part is we are going to determine the angular velocity of the shaft. Okay, the angular velocity of the shaft. So we are going to view in this direction now, where this is X and this is Y, and this is our Z, okay, I, J, and K. So we know that there's a center now. Okay, and then we are aware that this is our shaft. Over here is our point A. Over here is our point O. Then we have a arm. And this arm over here is connected to our planet. And we just found out that this is moving at 0.2. Okay. Okay, so we found that Vp is equal to minus 0.2 I. Okay. So from here, it's real straightforward. So we want to find what is our omega A. Okay, and we know that omega A is, I think it's rotating at that direction, but let's see. Okay, so from here we form, okay, so this one again, I'm going to make it, I'm going to assume. Okay, I'm not sure because planetary gears, the arm, you have to be careful. Okay, the arm can be in a different direction, or the link. So we can form the expression where Vp is equal to V naught, okay, plus by omega OP, or whatever you want to call it, okay, will still be the same, cross R P from point O. Okay. So from here, this is equal to minus 0.2 I. This will be equal to 0 because it's not moving anywhere. And our assumed direction is going in a what? Is going in anti-clockwise direction. Plus anti-clockwise omega OPK cross. Now from point A to the planet, or point O to the planet, right? We know that this is 0.8 or 80 millimeters, right? We know that this is 80. And then we know this is 40, so it's 0.12. So 40 plus by 80 is equal to 120. So we know that the distance from here to here is equal to 0.12 meters. Okay. So it's 0.12 positive J. Right. So minus 0.2 I. This will be equal to K cross J is negative, but both of them are positive. So it's 0.12 omega OP, and this is your I. Okay. So based on the I component, we have minus 0.2 is equal to minus 0.12 omega OP. Omega OP is equal to 0.2 divided by 0.12. So it's equal to 1.667 radians per second. And it is positive. Positive means the assumed direction is correct. So the direction is going this way. Right. So that is all that we are going to do for planetary gears. Now, in your design course, do you all learn planetary gears calculation this way or no? Or is it different? Different or the same? Different, right? Okay, so this is your planetary gears. Right. You know what? What I'm going to do is I'm going to stop here. I'll see you guys on Tuesday, on Monday. Okay. Thank you for your time. I'm going to check